Okay, we're going to take a look at a distance time graph. It's very important when you're looking at motion graphs that you are sure that you have a distance time graph and not a velocity time graph. Okay, so make sure that you check the axis here that says distance. Okay, so what can we learn by looking at distance time graph? It tells us the distance against time, obviously. So for this particular journey, we have something moving. Its distance is increasing as the time goes on. In fact, it gets to 2 meters at a time of 2 seconds. And then we can see that between 2 and 5 seconds, the distance doesn't increase. Okay, so if the distance doesn't increase, it means that it is stationary. Okay, and then this part of the graph, we can see that distance is increasing. In fact, it's increasing quite quickly, up to 7 seconds. So between 5 and 7 seconds, it actually does between 2 and 7 meters. So it actually travels 5 meters there, okay, in that 2 seconds. Then between 7 and 9, okay, its distance doesn't increase anymore, so then it remains stationary, and then its distance increases again. So what can we tell? We can tell that we have a constant speed. Here we have stationary. Again, here we have another constant speed. There's actually a faster constant speed than the first bit because it's steeper. That means it covers a bigger distance in a given time. Okay, and then again, when it's flat, it is stationary. Okay, and then again, we've got constant speed. One thing that we can work out is we can have a go at working out the speed for the 3 sections where we have constant speed. And I've labelled them 1, 2 and 3. Okay, so first of all we need the formula for speed because we need to lay this out properly. So speed equals distance over time. Sometimes speed is given as a v. I'm just going to use s in this occasion. And then we plug in the numbers. So for the first bit, it does 2 meters, travels 2 meters in a time of 2 seconds. Okay, and hence we have a speed of 1 meter per second. And I'm just going to double underline that. Part 2, we can see that its distance increases from 2 up to 7 meters. So in fact it travels a distance of 5 meters and it does that in 2 seconds. Okay, so again start with the equation, S equals d over t. Plug in the numbers, so it travels 5 meters in 2 seconds. Okay, so its speed is 2.5 meters per second. Okay, in the third part we can see that it goes from 7 up to 7.5 meters in a time of 1 second, okay, between 9 and 10. Okay, so again, formula, S equals d over t. We have half a meter over 1 second. Okay, so essentially 0.5 meters per second. Okay, the last thing, you may be asked to find the average speed for the whole journey. We've got speed which is changing, so there's parts where we have constant speed and other parts where we're stationary, but what about the whole journey? Can we work out an average speed? Well, yes, and the average speed is the total distance travelled divided by the total time taken. Now, from this graph, you can see that the total distance that we travel is 7.5 meters. And it does that in a time of 10 seconds. Okay, so let's calculate. Okay, so average speed equals total distance over total time equals 7.5 meters in 10 seconds over 10. Okay, so we end up with 0.75 meters per second.